Hello students, myself Ramesh Masuna, faculty ACE Engineering Academy. In this video, I am going to discuss GATE 2022 DBMS questions and their detailed solutions. From DBMS, like previous years, in GATE 2022 also, there were totally 5 questions are given. And these 5 questions are from 5 different topics, and these 5 questions covers total of 7 marks. And these 5 questions are from 5 different topics. One question is on relational model, one question on functional dependencies, where it is asked question to find the number of super keys. One question on relational algebra, the question is based on the concept of division operator. One question is on structured query languages, which is combination of nested query, correlated query, not exists operator, and set manipulation operators also. And one question is on transactions and concurrency control, which is based on the conflict serializability. And these are the 5 questions from these 5 different topics. In the relational model, one multiple choice question is given. In functional dependency, asked to find number of super keys. It is a numerical answer type question. In relational algebra, question is on division and it is multiple selection question. In SQL, the question given a table of data and asked you to find how many rows in the output of the query. That is numerical answer type question. And the last question is based on the conflict serializability, which is the multiple choice question. Here you observe 2 multiple choice questions, 2 numerical answer type question, 1 multiple selection question. So means all the questions are balancedly asked, like in the previous years also. There are totally 5 questions or 5 different topics, and all these 5 questions are also equally balanced. Now, here in this video, I am going to discuss each of these 5 questions in a more detailed way. Here it is a question. In a relational data model, which one of the following statement is true? The question is about is true. Which statement is true? Look at option A. A relation with only 2 attributes is always in BCNF. It is a true statement and option A is the correct answer. You may ask me, sir, why this is true statement? Let me explain you with a small example. Suppose I do have a relation with 2 attributes r of A comma B. And just think about the possible functional dependencies. The possible functional dependencies are A to B, or B to A, or both A to B and B to A possible. It means we have a 3 possible sets of functional dependencies on a relation with 2 attributes. In the first case, what is a key? A. In the second case, what is a key? B. In the third case, what is a key? Both A and B. Now here you look at, because in the first case key is A, left hand side is super key. So we can call it as BCNF. In the second case, B is a key, so left hand side is super key. Then we can call it as a BCNF. What are the keys? A and B, both left hand side of a dependencies are super keys. Then we can call the relation is in BCNF. Means in all the possibilities, we can say a relation with 2 attributes is always in BCNF. So it is a true statement. Now look at for option B. What is option B given? Every relation has at least one non-prime attribute. It is a false statement. It is not required to have at least one non-prime attribute. Let me explain with a small example. Suppose I have a relation R A B C having the functional dependencies AB to C and C to A. Now what is the key for this relation? AB is going to be a key because AB closure contains all the attributes of a relation. When A, if replaced with the C, because C is deriving A, means A is a prime attribute derived by C, we can replace A with the C in the key, so that CB is also a key. And we know that the attributes of a candidate key called prime attributes. Now, what are the prime attributes? Now, the prime attributes are A, B, and C. Here you observe all are prime attributes. We don't have a non-prime attribute, but what the statement is given? Every relation has at least one non-prime attribute. It is not mandatory to have a non-prime attribute. That's why option B is wrong. Look at option C. If all attributes of a relation are prime attributes, then the relation is in BCNF. Here, this statement is directly wrong. Why? Look at, again, you consider the same example. Here, all the attributes are prime attributes. What is the normal form of this relation? Because in the statement it is given, it is BCNF. What BCNF requires? Left hand side of a dependency should be super key. In AB to C, AB is a super key, no doubts. In C to A, C is not super key, but A is a prime attribute, means it is not satisfying the definition of BCNF, it is satisfying the definition of 3NF, then we can call R is in 3NF, but not BCNF. What was the statement given? If all attributes of a relation are prime attributes, then the relation is in BCNF. It is not BCNF, it could be 3NF. But given BCNF, wrong statement. Option D. BCNF decomposition preserves functional dependencies. It is a wrong statement. Why? Look at, what is the normal form of this example? 3NF. Suppose if I wanted to decompose this relation into 3NF, we have to separate violating dependency into one relation. BCNF definition is violated by C to A. I will take C to A in one relation. And R2, you should take one more table. In the table, the uncovered attribute is B and the primary key of decomposed relation is C. We have to take it. Now, here this decomposition causing the relation to have two attributes, and we know that relation with two attributes is in BCNF. And here if it is BCNF decomposition, C to A is satisfying in R1. What about AB to C? We can say AB to C dependency is lost, means dependencies are not preserved. But what the statement is given, BCNF decomposition preserves functional dependency, it is a wrong statement. So, what is the correct answer for the question? The correct answer for the question is option A. Here it is a question given, consider a relation R of A, B, C, D, E. 5 attributes are given with the following 3 functional dependencies. The dependencies are AB to C, BC to D and C to E. Then the number of super keys in the relation R is how many super keys? How do you find super keys? In order to find super keys, first you need to find candidate. What is the candidate key of this relation? When I take the left hand side AB to C dependencies closure, I am going to get all the attributes A, B, C, D, E, all attributes. When I take BC closure, I am going to get B, C, D, E, not all attributes. So, BC is not going to be a key for the relation. When I take closure for C, C and E, I am going to get it, but not all attributes. So, C is not a key. Because AB closure contains all the attributes, then I can call AB is a candidate key for the relation. If AB is a candidate key for the relation, AB called prime attributes. And what are the non-prime attributes? C, D and E. And these are the 3 non-prime attributes. With these 3 non-prime attributes, we can able to form how many combinations? 2 power 3. That is possible, means it is equals to 8 super keys. It means AB with non-prime attribute combinations will give you super keys. The number of super keys will be 8 super keys. How? Look at, AB is a candidate key. And what are the non-prime attributes? C, D, E. What are the possible combinations of C, D, E? Pi, C, D, E, C, D, C, E, D, E and C, D, E. Here you look, AB with pi, we will get AB, and you know that every candidate key is a super key. AB with C, ABC, with D, ABD, with E, ABE, with CD, ABCD, with CE, we are going to get ABCE. With DE, we are going to get ABDE. With CDE, we are going to get ABCDE. What is the definition of super keys? It is a set of attributes which is containing the candidate key AB. In all of them, we have a candidate key AB. So, totally how many super keys? 1, 2, 3, 4, 5, 6, 7, 8. So, totally we can say 8 super keys. So, the answer for the question is 8. 8 is the answer for the question. Here it is a question based on the concept of division operator in relational algebra topic. Consider the question. Consider the following 3 relations in a relational database: employee, brand and own. 3 tables are given. So that with this schema, we can understand that employee own some brand, right? So employee details are in the employee table, the brand details are in the brand table. Which employee owns which brand, that is there in the own table. Question is, which of the following relational algebra expression returns the set of EIDs who own all the brands? Set of EIDs who own all the brands. Here we have to compare one with all values of other relation. In algebra, we have to represent this one using a division operator. We call division operator. Now, what division operator will do? Let us an example. We have an employee ID, brand ID. If it is divided with brand ID, it is a query that EID, BID division with BID is going to give you EID for all BIDs, means employee ID for all brand IDs, means employee who owns all brands. It means we have to get an expression in this form where an expression is going to find EID, BID, means employee ID and what brand ID that employee owns and what are the brand IDs. If you perform a division between them, we are going to get employee IDs who owns all brand IDs in the output. Now, look at the first expression. Employee ID, brand ID of own, division with brand ID of brand. Means it is an expression like EID, BID, division with BID. It is going to give you EID who own all the BIDs in the output and EID in the output. So, this is a proper query and it is undoubtedly it is correct. And the question is multiple selection question. Because multiple selection question, more than one option may be correct. You have to check other options also. And here you look at EID, BID of own, division with pi BID of own. Here it is given a table own. Because it is given own, it is incorrect. Why? Because all brand details are there in the brand table. And which employee is owning which brand, that is there in the own table. Suppose there is some brand which is not owned by any employee. Then in such cases that brand is not in the own table. So it is not the correct output. That's why option B is incorrect. Look for option C. And moreover, option C is an equivalent expression for option A. So that option C is correct. Okay, you may be asking, you may be having a doubt that, sir, how this option C is equivalent to option A? Please prove me. Okay, let me show you with a small example. Here we have 2 employees, employee ID 1, name A, employee ID 2, name B. Okay, this is employee table. We have a brand table, brand 9, B1, brand 10, B2. Okay, 2 brands we have. Own table, we have 3 own tuples, employee ID 1 owning brand 9, employee 1 owning brand 10, employee 2 owning brand 10. Now, by looking this, we can understand employee 1 owning all the brands, because only 2 brands we have, 9 and 10, and employee 1 is owning all the brands. Employee 1 should be in the final output. Now, see, is it going to give the same output? Evaluate the query starting from the innermost. What it is finding? EID of own. What are the EIDs in the own? 1, 2, and you know that algebra eliminate the duplicates. Because it is 1, 1, 2, it shows only 1, 2. BID of brands. What are the brands? 9, 10. Between them we have a Cartesian product. The Cartesian product is going to give the output EID comma BID, which is all the combinations, 2 EIDs, 2 BIDs, 2 into 2, 4 combinations. What it is going to give you? 1 9, 1 10, 2 9, 2 10 in the output. This is an output of this expression. And this expression we have a minus with pi EID BID of own from the own relation. What is there in the own relation? We have 1 9, 1 10, 2 10 is there, correct? 1 9, 1 10, 2 10. If you perform minus between them, EID BID minus EID BID, the minus is going to give you the set difference. What this set difference give you? Values in the first but not in the second. Now when you look for the entire expression, 1 9 is there in both of them, 1 10 both of them, 2 9 it is there in the first instance but not in the second instance. So 2 9 is there in the first but not in the second. So that output of this query should be 2 9 and 2 10 it is there in both of them. This is the output of this entire expression. From this entire expression, what it is selecting? Pi EID. What EID it is going to select? 2. It is going to select 2. Means what output? Here we can say this is going to give you EID 2, right, minus. What is the outer expression? Pi EID of own. What are the EIDs of own? 1, 1, 2. 1, 1, 2 means 1 comma 2. What minus says? Just now we have understood. What minus says should be there in the first instance but not in the second instance. 1 is there in the first instance but not in the second instance. So EID 1 in the output. Who is EID 1? Who is EID 1? EID 1 is the employee who owns all the brands. It is satisfying the query. So that we can call option A and option C are equivalent expression. And the answer for this question is both option A and option C, and option D is incorrect. You can check why it is incorrect with respect to the table of data. You can easily understand. Here it is performing a Cartesian product between EID and BID of owns, and performing a division with BID, it is going to give you some incorrect results. So that answer for the question is both option A and option C is the correct answer for the question. Here it is a question based on the concept of structured query language and its subconcepts like nested query, correlated query and exists class, and also set manipulation operator. Here you look at what is given in the question. In the question they have given 4 tables: student, department, register and course. Details of students in the student table and department details in the department table and course details in the course table. If a student register for a particular course, that information is in the register table. 4 tables are given. And given a query, select star from student as S where not exists, select C number from course where D number equal D01, except select C number from register where S number equal S dot S number. The question is the number of tuples returned by the above query is numerical answer type question. How many tuples the above query is going to return? Here you look at first this query consisting of 2 inner queries. This is a first inner query. This is a first inner. And here you observe the first inner query is independent of outer query. What is the query? Select CNum from course where DNum equal D01. Look at in the course table, DNum D01 is there for this tuple and this tuple. And what are the course numbers? C11 comma C12. Now, the output of the first inner query is C11 comma C12. Okay, this is the output of the first inner query. And this inner query is independent, it is nested, it is completely independent. Always it is going to give you the same output C11, C12. Except, look at the second query, second inner query. Select C number from register where S number equal to S dot S number. Here you observe S dot S number. S is an instance of outer query. Whenever an instance of outer query, if used in the inner query, the 2 queries are said to be correlated. It means this inner query is going to be evaluated for each row of outer query. Means for every student, this inner query is going to be evaluated. And what this inner query is going to find? It is going to find the course numbers from registration table for that particular student. Means For the student in the outer query, it is going to find the course number that the student registered for every student. Chalo, we will check it one by one. For the first student, S01, we have to see the student S01 registered which courses. That course numbers you can see in the registration table. S01 registered C11 and C12 courses. So that the inner query is going to give the course numbers C11, C12. Now, what is the first query output? First query output is C11, C12, and the second query output also C11, C12. Between them, we have an except. Except means set difference minus. The first instance minus second instance will give you the output that is there in the first but not in the second. C11 is there in the first, also in the second. C12 also there in the first, also in the second. So, means it is going to give you the empty set. Nothing it is going to return. So, what is the output of this complete query, complete inner query? We can call empty set. Now, that empty set is there for the not exists operator. Now, here you look at what is exists of empty set. Exists of empty set is going to return false. Now, what is the not exists of empty set? Not exists of empty set, it is going to return true. It means it is returning true for the row of outer query. For student S01, for S01 it is going to return true, so that S01 James D01 in the output. This is there in the final output. So, the final output, here I am writing final output. Now, final output should contains the details of the student. What are the details of the student? S number, S name and D number. S number, S name and D number. What will be the S number, and D number? S01, James D01. James D01. This is there in the final output, and this is for the first row. Now, similarly, it requires to check the same conditions for every row. For the second row, look at S02. What the second inner query requires to find the course numbers registered by S02. Look, S02 enrolled C11 course. So, S02 enrolled C11 course means what is the output of second inner query? C11, correct? It is C11. Now, look at C11 minus C12, C11 minus C12 minus C11 will give you what? C12. Now, not exists operator on empty set only returns true, but you are getting result, it is going to return false. Because it is returning false, this S02 Rocky D01 is not going to be in the output. Next, you can check for the S03 student. S03, 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 S03. What are the courses? S03 enrolled C21, 22 and 23. Look at, it is going to return C21, C22 and C23. First instance minus second instance, that is C11, C12, means again you are getting the output. You are getting the output means this row is not going to be selected. Next, check for the next instance. Here in the next instance, S04. S04 enrolled what courses? Here C11 and C12. Now, C11 and C12 enrolled by S04. So, what is the output of second instance? C11 and C12, so that it is going to give you empty set. Exists on, not exists on empty set returns true, so that you can see S04 Jane D01 in the output. S04 Jane D01 in the output. And we have to continue this process even for the last row. Look at S05. S05, S05, C11, C21. Now, what is the output of second query? C11, C21. What it gives you? C12 in the output. It is mean that when you have an output, not exists of output returns false. It is false for S05 also. So, for every student, we have verified registration table for the query of second query output. And in the second query based on second query output, we have decided which students are going to be in the output. The final output contains S01 James D01 and S04 Jane D01. So the number of rows returned by this query is equals to 2. 2 is the correct answer. Here it is a question based on conflict serializability concept, which is from the topic of transaction management and concurrency control. Look at the question. Let Ri of z and Wi of z denote the read and write operations on a data element z by a transaction Ti respectively. Riz is called read and Wiz is called write. Consider the schedule S with 4 transactions. Here schedule S is given. We have 4 transactions. Based on the 4 transactions, we have 1 operations. Now question is, which one of the following serial schedules, these are the serial schedules given, is conflict equivalent to S? Which serial schedules are conflict equivalent to S? How we have to find it? Simple. We have to construct a precedence graph for the schedule so that we can easily answer the question. Now in a precedence graph, we have to have 1 vertices for each transaction. 4 transactions, so that I am going to have 4 vertices, 1, 2, 3, 4. Look at, we have to draw edge for each conflict operation. Look at R4X, and before we verify what conflicts are there for R4X, what are the conflict operations? Read write, write read, write write on same data by different transactions. Now look at this, read is going to conflict with write operation of different transaction on X. Look at any write operation on X. Why? This is a write operation on X. That is a transaction 4, this is a transaction 2, means R4 and W2X is going to conflict. Means we have a conflict from 4 to 2. Draw an edge from 4 to 2. This is why, this is why. Now continue with the second operation. R2X conflict with write X of other transaction. Look at write X's. This is write X. This is a transaction 2. It is also a transaction 2. Same transaction will not conflict. Why? Why? No conflict operations. R3X. R3X is going to conflict with write X of other transaction. Here write 2X is there. R3X, write 2X. Means we have a conflict from 3 to 2. Draw an edge from 3 to 2. Next, R1Y. Read Y is going to conflict with write Y of other transactions. Read Y. It is write Y, but transaction is same. This is write Y, transaction is different. 1, 2, 3. Now 1, 2, 3. We have an edge from 1 to 3. Next, this is read 4Y. No conflict. Write 1Y conflict with read Y and write Y of other transactions. We have a write Y. Transactions are different, means conflict from 1 to 3 already there. Write 1Y, read 4Y. We have a conflict from 1 to 4 also. Then we have a edge from 1 to 4. Now, write 2X conflict with read X or write X of other transaction, but not there. Here write 3Y conflict with read 4Y, because write read conflict is there of different transactions. 3 to 4. Now draw edge from 3 to 4. Now this is a precedence graph. Now question is, which of the following serial schedules is conflict equivalent to S? Which is conflict equivalent to S? Now how to find which is conflict equivalent to S? As you know that we have to perform a topological sort on the precedence graph to find the serializability order. That is one solution. But what I recommend you is, whenever options are given, so better you check with an options. Now a vertices with in degree 0. In degree 0 will be the first vertices. Now look at in degree 0 is there with transaction 1, transaction 2 in degree 2, transaction 4 having in degree 2, 3 having in degree 1. So means the first vertices should be in the order will be T1. Because first vertices should be in the order T1, so that option C and option D are incorrect. Now in topological sort, we have to remove the first vertices along with outgoing edges, means these edges are going to be deleted. So I will be deleting. Here I am going to delete the vertices along with outgoing edges. I am removing. Now, after I removed the vertices along with outgoing edges, what you have to do? Next vertices with in degree 0 will be the second vertices. Now, next vertices with in degree 0. Now, 3 is having in degree 0. 3 is having in degree 0. Look at. Now, what is the in degree for 3? 0. In degree for 2 is 2. In degree for 4 is 1. So, next vertices will be 3. Because next vertices will be 3, here it is given 4, it is not possible, B is incorrect, option A is correct. Over. Solution is over. When I am sitting in the examination hall, once I got a solution, I can stop the process. This is the best way of eliminations. But when you are preparing for it, you have to solve the entire one. Now you have to remove 3 along with outgoing edges. Chalo, I will delete all the outgoing edges of the vertices 3. Now look at. Now next vertices with in degree 0 is for transaction 4. Now that is 4. Here you look at 4, correct? 1, 3, 4. And now you remove 4 along with outgoing edges. Only one vertex is left, that is 2. Now what is the order of serializability? 1, 3, 4, 2. That is matching with option A. That's why we can say A is the correct answer for the question. These are the 5 questions asked in GATE 2022 from the subject DBMS, and these 5 questions covering totally of 7 marks. Hope you understood. Thank you.